Assalamualaikum and very good morning to all of you that will watch this video. My name is Muhammad Fahman bin Muhammad Shafatil. I am from University Technology Malaysia from BEET section 1/2. Today I would like to show you on how to do experiment that relate to friction. As we can see, the procedure that given for friction property and the link simulation that we will use. So this is the step that we will apply to the simulation. After this, first at all, I apologize due to my face cam problem that can synchronize with this app. I don't know why. So let's go through to our main topic. This is the simulation that we will do. The link we get from the lab. Okay, it's select friction. Okay, the simulation show you the one robot and one box. Okay, for the first simulation, we choose the 50 kg mass into this box and try to apply the friction that we can see if we put the apply force for this 50 Newton. Okay, as we can see, the robot start to push the box. Okay, we push the button play. It doesn't move the box because the force is not enough to push the 50 kg box, and to move this we need to put more force, and as we can see that that box start moving at 150 Newton. So for 50 kg box, the apply force that we need to push this box is 150 Newton, and friction force is 94 Newton. So for the second experiment is to level up the mass of the box from 50 kg to 100 kg and try to push it with the lot friction, and we try to see what happened in this simulation, and we can start now. So I try put a step by step, and we can see the robot cannot push the box because the friction surface is a lot. So if we reduce the friction surface, as we can see, the robot start to move, and we put the value. We can see robot start to push the box, and after that release the box. When we put again a lot of friction, the box immediately stop moving. So that's all from me. I hope this video can help you to do this simulation. I pass it to the to my others teammates, teaming long.
right? Teaming long, and then I will here show the simulation of part B, which is the coefficient of static friction. Okay, so first we go to the link, this link. Okay, this is the link, and then you say choose force and select inclined plane with friction. Okay, so this is the thing. So this is the page we want. Okay, this is the simulation. Okay, so next procedure is set the angle alpha to 0 degrees, mass of M2 to 10 kilogram, coefficient of friction between M2 and surface is 0.25. Okay, so mass of M2 is 10 kilogram. Okay, is correct. And then the alpha equal to 0 degree is correct also. And then the coefficient of friction between M2 and surface, we adjust this to 0.25. Okay, back to the procedure. Then we slowly reduce the mass of M1 until the M2 is barely moving towards M1. And then record weights of M2 in table B1. Okay, so first we set the mass of M1 larger first. Okay, so okay, we start from 3.8 kilogram. Okay, we click run. As we can see, is the block of M2 is moving towards M1, so we don't want that. Okay, we need to decrease the mass until M2 is barely moving. Okay, so we keep decreasing the mass. Okay, we're decreasing the mass. Okay, okay, so here is 2.7, and we can see the block is moving very slow. Okay, so we keep decreasing. Oh, okay, 2.6, 2.7, run. Okay, still moving at 2.7 kilogram, and then we decrease to 2.6 kilogram. 2.6 kilogram, and it's still moving, and then we decrease to 2.5 kilogram. Okay, we can see 2.5 kilogram, the block of M2 is stop moving. That means I would say, yeah, 2.5 kilogram is the maximum static frictional force is insert here. Okay, so when we adjust it to 2.6, okay, the force is already exceed the maximum static friction, so the M2 will move towards M1. Okay, so we need to observe the static friction, so we adjust it to 2.5. So what we need is 2.5 because the block stop. Okay, so we record 2.5 kilogram to table B1. Okay, okay, reduce the mass of M2. So this is the table B1. Okay, so I already done all the things. Okay, I have record all the mass of M1. So for the first M2 equal to 10 kilogram, just like what I do before, it's 2.5 kilograms. So I write here 2.5 kilograms. And then we need to keep decreasing the M2. So it's to 8 to 6, 4, and 2. And then I recorded it 2, 1.5, 1, and 0.5. Okay, this is because we need to do more, and then we can get an average result. And then to find the static frictional force, we first calculate the force of M2, and this is the forces of M2. Then we calculate the forces of M1. This is the forces of M1. and then we use the formula to calculate the static frictional force. And then to calculate static frictional force, the formula is m1 divided by m2, and then you get the value of the static frictional force. And then if you draw a line graph, the graph will be, directly proportional. Okay. And then we proceed to the next procedure. We adjust the angle alpha equal to 30 degree. Then the mass of M2 is the same, COF is also the same. So back to here, we adjust to 30 degree. Oh my god, 30 degree. Okay. So same, we reduce the mass until M2 is barely moving towards M1. Okay, so we basically do the same thing. Then we click run. Okay, it's still moving. We decrease some more. Okay, it was moving very slow, and then we decrease it slowly. Okay, as we can see, 7.2 kilogram. It moved very slow, and then it stopped at 0.1, and then we'll record this 7.1 into the table. Okay, yeah, so I also done everything 7.1, 5.7, and then later on. So to calculate the static frictional force, we also use the same thing. Okay, we calculate the forces of M2 and the force of M1, and then we divide M1 with M2, and then we get the static frictional force. So we have 5 results, so we use the average result. Okay, we plus them all, and then we divide by 5, and then plus them all, divide by 5, and then we get the result. And then this result, this average, divide by this average, and then we'll get the answer. So the calculation is here. This will be the calculation. Okay, M1 is 14.7, and this is the average result of the table before. This is for uh, angle 0 degrees. Okay, so we get the static frictional force is 0.25. This is the maximum static frictional force, and then this is how we find the coefficient. Here, the coefficient of static friction. Okay, thank you.